In example 2, we begin the investigation of patterns when multiplying polynomials. Just like in A1, when we looked at the differences to find that the constant differences had a pattern, we can do the same thing when multiplying polynomials and looking for patterns. And so one emerges when we multiply something by x minus 1. And so we're going to generalize the pattern that emerges by writing out an identity, which means it's going to be true for all values of x. So, on the table there, you see that it's set up x and minus 1. Right? Each term gets a column, each term gets a row. X to the fourth, x cubed, x squared, x, and 1. Right all from there. We complete the tabular method by filling out x times x to the fourth is x to the fifth. Right? 1 bigger than what we started with, x to the fourth. We do the rest, and but what you start to notice is that x times x cubed is x to the fourth. Negative 1 times x to the fourth produces the conjugate x, or negative x to the fourth, and those two are going to cancel each other out, just like these two, and these two, and those two, and so you're left with 0x to the fourth, 0x cubed, 0x squared. And so the identity comes here. When we multiplied this x minus 1 times this quartic function, we got x to the fifth minus 1. So here's what the pattern suggests. And here's the identity that I want you to use in the coming examples. The pattern suggests that if you multiply by x minus 1 times a polynomial, no matter how big of a degree, that this will be the result. This is a connection to a quadratic identity that you should have learned in Algebra 1. The quadratic identity generalized, it says that x minus 1 times x plus 1 is x squared minus 1, and that's exactly what's going on here. Right? And so x plus 1, x, right, we have to add 1 to the exponent, and that's where we get 2. It's also, more generally, the difference of squares formula, which is also something you should have learned in Algebra 1. We will explore this last identity in more detail in exercise 2 and 3.